2-8 deals with solving equations involving absolute value. We're slowly but surely rolling into cooler and cooler and more challenging concepts of algebra here. The problem says to evaluate the absolute value of m plus 6 minus 14 if m is equal to 4. Well, the first thing we're going to do is we're going to use substitution and substitute the 4 for your m value. And when you do that right here, you get 4 plus 6 is 10, so we have the absolute value of 10. So we know now that the absolute value of 10 is 10 minus 14 is going to be where we're going. We're going to take it from there, and that was substitution 2, by the way. We're going to take it from there, and we're going to use the definition of absolute value next. That's how you would describe that step. According to the definition of absolute value, the absolute value of 10 is 10. Good. Substitution, 10 minus 14 is negative 4. Easy math. Doesn't get any easier than this. We're going to get negative 4 for a final answer. This one should be pretty clear and basic for you. But let's see what else the future holds. There are 3 types of open sentences involving absolute value. The first one says the absolute value of x equals n. The second one says the absolute value of x is less than n. And the third one says the absolute value of x is greater than n. Now, I know that sounds confusing, so let's take a look a little further. In this lesson, we're going to continue just the first type, okay? We're going to look at the concept, the absolute value of x is equal to 4. We'll deal with the less thans and greater thans later down. It'll be a little more challenging, but so we're not jumping straight into that. Let's just focus on the concept, the absolute value of x is equal to 4. If you think about it, that means first off, the distance between 0 and x is 4. We know that's the fact because that's the definition of absolute value. It's how far that number is from 4. But there's 2 different numbers that have a distance of 4 units from 0. And those values are negative 4 and 4. You could have, so therefore x could equal negative 4 or x could equal positive 4. So you write this sentence here. If x is equal to negative 4, then x equals negative 4. If the absolute value of x is negative 4, then we know that either x equals negative 4 or x equals 4. And we can write this in set notation saying the solution set is equal to negative 4 and 4. Either one is a very valid answer, and we have to include both of them. Now, I know this is getting to be a lot to swallow, so we're going to go back and look at the top real quick. Actually, not too quick. The only thing we're focusing on right now is this concept. The absolute value of x is equal to n. The next section, this we're going to worry about later. That's the value of x is less than n, and the absolute value of x is greater than n. We're going to do another day. We're only looking at the absolute value of x is equal to 4. And we know that since the absolute value of x is equal to 4, then the distance between 0 and x is 4, as indicated on that graph. Therefore, your x value could be negative 4, or it could be positive 4. Either one is a perfectly legitimate answer, and we have to include both of them in our solution set. For each absolute value of the equation, we must consider both cases. To solve an absolute value equation, first we're going to isolate the absolute value on one side. We're going to pretend the absolute value is the variable. I taught you to isolate the variable last year. So now we're going to work on isolating the absolute value on one side of the equal sign, and if it's not already there by itself. Everything else will go to the other side. Here's some key concepts to look at in absolute value equations. When solving equations that involve absolute values, there are 2 cases to consider. First, case 1, the expression inside the absolute value symbol is positive or 0. The other possible option is the expression inside the absolute value symbol is negative. Symbols for any real number, a and b, if the absolute value of a is equal to b and b is greater than 0, then a is equal to b or a is equal to negative b. Hold on, Mr. Reed. That's getting kind of confusing, so we're going to pause it. I want you to write it down, and then we're going to look at it again. Okay, now hopefully you have it written down now, and we're going to look at this in bite-sized pieces. For any real numbers, a and b, okay, those are just represent numbers in the real number system. It says that if the absolute value of a is equal to b, and b is a number greater than 0. Okay, so if the absolute value of a is equal to b, we know that b is going to be a positive number. Or it could be 0. If a is 0, the absolute value of 0 would be 0, and then this rule wouldn't apply. So we're going to assume that a is a non-zero number, therefore b would be a non-zero number. So b must be greater than 0. If b is greater than 0, then a is going to equal to b, or it's going to equal to a negative version of b. Let's put some numbers to this and see if we can understand it a little bit better. The absolute value of d is equal to 10. Therefore, we know that d must equal to 10, or d must equal to negative 10. Because both negative 10 and 10, the absolute value of negative 10 and 10 are both equal to 10. Solve each equation, then graph the solution set. Let's take this a little bit further. You have the absolute value of f plus 5 is equal to 17. Our absolute value is already on one side. Our 17's on the other side, so we don't have a lot of isolating that has to be done here. We're going to start off, of course, with the original equation. Write that on your paper. And then we can say that, well, we know two things are going to be true. Either f plus 5 is equal to 17, or f plus 5 is equal to negative 17. We can say that because we know that f plus 5, the absolute value of f plus 5, is equal to 17. The number inside there could be positive or negative because it makes no difference what it is. The absolute value of that number is going to equal to 17. So remove the absolute value bars, f plus 5 has to equal 17, or f plus 5 has to equal a negative 17. From there, we can break it down a little further. Let's look at case 1 and say, well, if f plus 5 equals 17, we're going to use the addition property of equality. Actually, that would be the subtraction property of equality. So let's take and one line that out, and you take and write subtraction property of equality on your notes. Subtract 5 from both sides, then use substitution, and we know that the answer would be 12. F would equal 12. But that would only apply if f plus 5 equals 17. But we don't know for certain that f plus 5 equals 17. F plus 5 could equal to negative 17, which was case 2. Once again, we're going to go through, we're going to use our subtraction property of equality. The 5s on the left will cancel each other out, and in this case, f is equal to negative 22. So you could say that your answer is going to be, let me back up for just a second, your answer is going to be either f equals 12 or f equals negative 22. Both are legitimate answers and both are required. Of course, you can find both of those points on the number line. The f equals negative 22 is over here on the left, and the f equals 12 is over there on the right. And we'll deal more with number line stuff in the future time. Let's look at another example. The absolute value of b minus 1 is equal to negative 3. If that's the case, we know that negative 3 means the absolute value of b minus 1 equals negative 3 is the distance between b and negative 1. So b and negative 1 is equal to a negative 3. Since the distance cannot be negative, the absolute value of a number cannot equal a negative number, this is an empty set. There is no solution. Okay? Theta, empty set, null set, all these words describe what you have here, or an empty braces. So that one you can't work. Anytime you end up with a problem that shows an absolute value is equal to a negative, there's your answer. You don't have to go any further than that. When given 2 points on a graph, you can write the absolute value equation for the graph. Let's take, for example, if we had the points 11 and 19, and we want to write an equation involving absolute value. To do that, we could say, well, let's see, the first point that is the same distance from 11 and 19 is going, the point that is the same distance from 11 and 19 is 15. So that's going to be the midpoint, the point which is halfway between them. And we can see that the distance from 15 to 11 is 4, and the distance from 15 to 19 is 4. The equation, therefore, would be the absolute value of x minus 15 is negative 4. 15 being that midpoint, and 4 is the distance between the midpoint and the 2 points that we were given originally on the graph. And that is what you would call an answer. That's what you would box as your final solution. Now, if you were to work those backwards, proving your answer, you could say that x minus 15 therefore must equal to 4, or x minus 15 must equal to negative 4. Because remember, the way it is set up here, the number that's inside the absolute value could be positive or it could be negative. So it could equal to a positive 4 or it could equal to a negative 4. And that's what we did. We set it equal to a positive 4 and we set it equal to a negative 4. From here, we can work it out. That step, of course, would be the addition property of an equality, adding 15 to both sides. The 15s on the left would cancel each other out, leaving x equals 19. Hey, there's that point we started off. Or we could add 15 to both sides of the other one, cancels out, and get x equals 11. Hey, there's the other point we started out with. See how that works? Easy to do these things. It really is. You just got to take a minute and soak in the concept, realize that the number that's inside those bars is going to be a positive or a negative, set it equal to a positive or a negative, and work it accordingly. So if you had been instructed to solve this problem, the absolute value of x minus 15 is equal to 4, you would solve it using this right here. And as you can see, once again, your x equals 19 is circled in red up there on the number line. Your x equals 11 circled in green up there on the number line. That would be showing your work, and all said and done, like I said, they're not that bad. They're pretty simple concepts. Your assignment is page 105, numbers 13 through 75, odd. Remember, caveman with a spear plus a bear equals fat caveman. Caveman without a spear plus a bear equals fat bear.